discussing the organic chemical technology course, and we have discussed about the various processes which are being done in petroleum refining, and today we will be discussing one of the very important topic in case of the petroleum refining, because the importance is increasing because of the stringent environmental standards are being imposed, and at the same time sensitivity of the catalyst. So, desulfurization process and recovery of the sulphur. This is a typical sulphur recovery plant of the IOC Panipat. Coverage of the lecture that will contain about the introduction, sulphur requirement in different gasoline and diesel, because this is the one of the driving force which is requiring the desulfurization process, and at the same time the requirement of the catalyst, because the catalyst which we are using in the various process, they are very sensitive. So, we need the desulfurization process. So, that is also second actually driving force apart from the sulphur requirement in the gasoline and diesel. Worldwide crude oil quality, because you see the crude oil quality is varying. Earlier we used to get the sweet crude, low sulphur crude, but now with the coming of the heavier crude, the sulphur content that is increasing. Even the crude which we have got in Rajasthan, that is high tan crude and with high sulphur. Reactivity of the sulphur compound, because what is happening during the treatment process, the reactivity of the various sulphur compounds which are present, that also poses problem in removal. So, that is the we will be discussing in brief about the reactivity of the various sulphur compounds with the mercaptan to thiophenol that is present, and so how they are reacting during the desulfurization. Sulphur output, because there are various sources of the why we need the desulfurization, why we need the sulphur recovery plant, because huge amount of the SO2 gas or H2S gas or the other gases that is being generated. And so, what are the various sources? Because in all the processes, as we discussed earlier in the previous lectures, whether it was the catalytic reforming or the FCC or the this hydrocracking, in all the process the prerequisite was treatment of the feedstock before it was going to the main process, because the sulphur, that is one of the highly poison catalyst poison material, and so removal that was very important. And so, the various sources what a process used to remove sulphur from the different products. Sulphur recovery units characteristic, Merox process, Merox sulphur recovery from H2S, because there has been continuous development in case of the sulphur recovery processes, because what has happened, the conventional Claus process still the emission, some of this emission of the sulphur compounds were there, to how to minimize that emission. So, the super Claus process and some new development that has taken place in the, because the Claus tail gas that was also containing, and so how to treat that Claus tail gas. So, we will be discussing about the Claus tail gas treatment process. Some of the other development which has taken place, that is the super soul process that has been developed by Indian Oil Corporation, that is the indigenous technology that we are having. Introduction about the why we need this, the desulfurization process or the sulphur recovery, and why it has become important. Sulphur compound, hydrogen sulphide, mercaptan, disulphide, thiophenes are inherently present in the natural gas and the crude oil, and their presence even in a small quantity is undesirable, must be removed to ppm level in order to avoid catalyst poisoning, reducing the corrosion problem and meet the environmental standards, because the corrosion problem is also one of the severe problem because of the coming of the high tan crude oil and at the same time high sulphur crude oil. The level of the sulphur, as I told you, that has been increasing. So, the level of the sulphur in the past 2 decades has steadily increased due to use of more and more heavier crude, use of cheaper high sulphur crude, which has forced the refining industry to go for additional facility like ultra desulfurization for gasoline and diesel to meet the requirement of the stringent sulphur emission standards. Because whatever the products you are getting, whether it is the diesel, kerosene or gasoline, that has to be desulfurized before it is going for the end use. And so these are the some of the driving force which has led to the development of the various sulphur recovery process or the desulfurization process. Sulphur is the one of the major impurities in the heavy crude, resulting higher concentration of sulphur compound in the undesulfurized product stream. Product stream is not the final product only, but also the feedstock to the various processes like FCC, hydrocracking, catalytic reforming. Already we have discussed because before it is going to the main reactor, the feed is pre-treated, and then even after the product which you are getting, they contain the traces of the sulphur compound, and to meet the environmental standards of the 50 ppm, definitely the product has to be treated. Sulphur content in the crude varies widely depending on the origin, because this also varying from one place to another, one well to another and one region to another. So, that the wide variation we found in the crude oil quality also with respect to sulphur. The variation is considerable, and this impact the process scheme as well as the product slate. Due to increasing environmental concern, stringent limit on sulphur levels in fuel are being implemented whether you take there has been continuous reduction in the SO2 emission as per the Euro norms, that is Euro 1, Euro 2, Euro 3 and Euro 4, and now to achieve the 50 ppm, that is a big challenge for the refinery to achieve target of the sulphur 50 from desulfurization. So, ultra desulfurization, deep desulfurization, hydro desulfurization is required, which is an additional capital cost, always an energy intensive step, and sometimes the loss of your hydrocarbon is also there. This is I was telling why we are going for the desulfurization process. If you see these figures from the 2000 to the changes which is taking place, now the BIS standard 1000 it was earlier, Bharat 2 it was 500, Euro 2, Euro 3 150, Euro 4 50. So, that is the level of the SO2 that has to be maintained in the gasoline or the diesel. So, definitely you see that there is a lot of the change in the standards also. So, this is one of the reason why we are going for the recovery of the sulphur, and at the same time you see the sulphur, that is also one of the very important feedstock for the various chemical plant. Only problem that the generation of the sulphur which is there, it is not so huge as it is required, whether it is by sulphuric acid or other plant. This is the worldwide the crude quality, how it is changing, and if you see the 1985 to 2010, the sulphur contained crude oil variety from lighter to heavier sulphur in the residue, that is also increasing. So, these are the some of the problems which needs the desulfurization of the product, desulfurization of the feedstock to the various process, and during this process from the various stream we are getting, because one of the major source of the sulphur in the refinery is the FCC. If you see the FCC, because the feedstock which is going to it is pre-treated. So, one of the major source of the sulphur is the FCC. This is the sulphur content of the various crude, which indigenous crude and other crude, that is there. Here it is the Bombay High 0.1, Bonny 0.1 or heavy 2.87. So, you can see the wide variation is there in case of the sulphur content in the crude. There are basically 4 types of the crudes available around the world that already we discussed. We are having the light sweet, light sour, heavy sour, extra heavy sulphur. So, this is how the sulphur content that is varying, API gravity that is varying. In case of the light it is 30 to 40, light sour is 30, but in case of the heavy sour it is more heavier feedstock is there. So, this is how the changes that is taking place in the crude oil availability in the future. It is expected that more and more heavier crude oil that will be available, and you will have to adjust your processing scheme in the refinery accordingly just to meet the environmental standards, because definitely now you will have to supply the fuel of the Euro 4 norms even in India. So, how do some of the refinery already they are ready to supply the fuel of the Euro 4 norm. So, definitely these are some of the changes that is taking place in the refinery processes because of the coming of the heavier crude or the high sulphur crude. These are the, I was telling, the reactivity of the sulphur compound, relative reaction rate, boiling point of the various component, which is creating lot of problem in case of the. So, depending upon the, you see the removal of the mercaptan dimethyl sulfide that is more easier than the thiopene or the benzothioene. Now, let us discuss what are the sources from where the sulphur is coming in the stream. So, sulphur contained in the finished product, sulphur emission into atmosphere in form of the SO2. This is coming to the, because this is we are discussing about the sulphur output from the refinery, sulphur recovery in sulphur recovery unit, because earlier you see the Claus process or the modified process have been up to 97%. So, some of the sulphur compound is still remaining. So, because of that reason now we are going for the, has been development in the sulphur recovery unit to achieve maximum removal of the sulphur compound. Sulphur distribution, typical refinery is sulphur in the various products 58%, product sulphur 41%, sulphur emission 1%. So, you see the major contributor are the products and the various products which are getting from the refinery operation. These are the some of the sources which need the removal of the sulphur, and we are doing the desulphurization for removing the sulphur. LPG treating unit where we are removing the sulphur, because these are the all the gases which are removing, again they are going further processing for the removal of these gases from the gas stream, and then finally it is going to the recovery of the sulphur by Claus, modified Claus or any other modification. So, gasoline hydro treating unit, this is also again the hydro desulphurization process, aviation turbine fuel, Merox process and hydro treating that we are doing, diesel hydro treating process is there, hydro desulphurization, sulphur lands up in the fuel gas as H2S during the hydro treating process. H2S in the fuel gas produces SOx while burning in the fired heater, environmental 50 ppm while burning the fuel gas. This is the environmental standard of the emission. Hydro treatment process. Hydro treatment of the various steam from refinery and the petrochemical industry has become integral part in order to meet the feed standards of the various processes, in order to avoid catalyst poisoning, improving the quality of the products and meet the environmental standards. Hydro processing technology consists of any one of the various processes that we are using. That may be the pre-treatment, it may be the hydrocracking processes, hydro treatment of the fuels and lubricants. So, these are the some of the hydro treatment process. Pre-treatment of the hydro treatment of the naphtha and gas oil, residue for the catalytic residue from the catalytic reforming, catalytic cracking and the hydrocracking in order to remove the impurity sulphur, nitrogen, heavy metal, etc. Hydrocracking processes, hydro treatment of the fuels and the lubricant. This is the actually the, if you see the what are the major sources of the sulphur and recovery process in the refinery. The crude oil distillation unit, FCC, or the residue fluid catalytic cracking, gases, LPG, hydrocracker, hydrotreating gases, coker, fine gases, and the LPG. So, these are the some of the sources which normally from the gases we are having the amine absorption and then the amine regeneration. The gases after the final removal, that is going to the sulphur recovery, we are getting the sulphur. It is even the tail gases which are there, that is going for the further removal, and the finally it is going to insulation. And the definitely one of the another source in the refinery, because of the processing of the sour crude, that is the sour water from the various steam. So, the sour water, the gases from the sour water by steeping, that is removed, and then again it is going to the sulphur recovery plant. This is the actually the same process that we discussed. Sulphur recovery units characteristic: small to medium sized sulphur recovery units from a few tons to a few hundred tons per day go out to refinery, because the sulphur content is low, the sulphur production is less. But in case of the Reliance Jamnagar, where they are processing more heavier feedstock, the production of the sulphur is high. Sulphur recovery units. Feed composition varies linked to the refinery operating mode and crude feedstock. High flexibility is required, multiple trains. Acid gas always reach high H2S content. Ammonia from the sour water steeper always present, sometimes in the relatively high quantity, because ammonia that we are using in case of the distillation column, crude distillation column, or even in case of the FCC also, for as a to get rid of the corrosion problem. So, these were the some of the sources we discussed about the from where the actually the sour gases or the sulphur gases that is coming, and the now let us discuss about the sulphur recovery unit. Sulphur recovery unit consists of recovery of sulphur from H2S present in acid gas, from amine treating regeneration unit, and H2S from the sour water steeping section, which I told you that there are two sources. One, all the gases that is going to the amine absorption, and after the amine absorption again the after regeneration of the amine, the gas steam that is going for the treatment, and other source of the sour gas H2S, that may be from the water steeper section from the sour water. Hydrogen sulphide content of the feed gas is converted to elemental sulphur, because this is how we can get rid of the sulphur compound. So, amine absorption and regeneration, that is the process which I told you, because first step, that is the absorption of H2S bearing steam and regeneration of amine. H2S rich steam from amine regeneration is sent to the sulphur recovery unit for recovery of the sulphur from the gas. Now, let us discuss, because this is the Merox process, that is the integral part of the refinery, and in all the refinery they are having Merox process. So, the Merox process is used in the refinery for controlling the mercaptan sulphur in gases, LPG, naphtha, and other petroleum fractions. The process is used for chemical treatment of LPG, gasoline, and distillate from the FCC or the hydrocracker unit, that may be once through, or the two stage, that is OHCU means once through, and FCCU means the fluid catalytic cracking unit, to remove the mercaptans. Mercaptans are either extracted from the steam or sweetened to acceptable disulfide, because the disulfide smell is not there, and but removal the both the mercaptans and disulfide, that has to be removed. For treatment of the light feedstock such as LPG, no sweetening is required, as mercaptans are nearly removed by extraction. So, that is the two types of the method which I told you, the extraction and the sweetening, that is the you can remove the mercaptan or the from the gas stream. However, feed containing higher molecular weight mercaptans and may require a combination of Merox extraction and sweetening using the catalyst, because they are in the process of the sweetening we use catalyst. Catalyst promote the oxidation of the mercaptans to disulfide using air as the source of oxygen. Merox treatment can in general be used in the following ways to improve the lead susceptibility of light gasoline, but that problem is not there. To improve the response of the gasoline, because already lead has been phase out. To improve the response of the gasoline stock to oxidation inhibitors added to prevent gum formation during storage, to improve odor in all the stack gases. Merox treatment unit can in general be used to meet the product treatment, to reduce the sulphur content, to reduce the sulphur content of the coker, FCC, olefin, to save acid consumption in alkylation process. This is the process that we are using, the pre-treatment, extraction and the sweetening. So, this is the method, these are the reaction that is taking place. You are treating with the NaOH, sweetening, oxidation, this mercaptans to disulfide that is taking place. So, these are the some of the reactions which are taking place in extraction, and the this is the caustic we are using for the extraction. So, in the extraction and the sweetening processes. Sulphur recovery from H2S, because whatever this H2S that we are getting, the conversion of the H2S or mercaptan to the sulphur, that is very important. The sulphur recovery now has become one of the most critical aspects of the sulphur management and affects the emission sulphur dioxide significantly in the refinery, because if you are not properly removing, so this SO2 emission that will be there, and even it is not the requirement of the fuel only, it is the requirement of the refinery stack gases emission also to have the lower sulphur dioxide in the stack gases. And their standards are of course that they are for the emission of the SO2 or emission of the particulate matter from the FCC, which is one of the main sources, and that is available in the standards given by the Central Pollution Control Board. Now, let us discuss about the sulphur recovery in more detail. There are two sulphur recovery process, that is the Claus process, the conventional Claus process used earlier. Now, we are talking about the super Claus process, because you see in case of the Claus process, the removal of the sulphur compound that was less and the recovery part that was less, and so this tail gases was containing a lot of the sulphur compound, and so to just to minimize that emission, again the conventional Claus process that has been modified. The conventional Claus process has only even 99 or 97 to 99% sulphur recovery. In order to meet the sulphur emission standards, now Claus process has been improved substantially to meet the standard. New processes are characterized by new catalytic, COS and carbon disulfide hydrolysis, increased recovery, direct conversion of H2S to sulphur by oxidation, that is what we are doing in case of the super Claus process. This is the typical sulphur recovery unit. the sour gas, that is going to gas treating unit, sweet gases, then the acid gases, that will go to the recovery unit, Claus process, then the tail gases from the Claus process, again that will go to the further treatment. So, tail gas cleanup unit, additional recovery, then finally you are getting the sulphur and the gases that will go up incineration and then to the chimney. So, this is the process that we are having in case of the typical sulphur recovery unit, and here you see the tail gases, because this was the additional modification that, that has been done with the coming of the stringent standards, and so the sulphur recovery tail gas that is treated, and finally the sulphur compounds that can be used in the various processes. Let us now discuss in the Claus process in more detail. Claus process is vapor phase oxidation process using alumina catalyst. In the Claus process, H2S is burned to form, which reacts with H2S to form elemental sulphur. Sulphur is formed in vapor phase in combustion chamber. The sulphur vapors are condensed and drained to sulphur pit in the waste heat boiler, thus generating steam. In Claus process, the recovery is around 95 to 97%. If you are having super Claus, then the your efficiency that is going high. So, the function of the Claus process, this is the these are the some of the reaction that is at the catalytic region, and this is the hydrolysis part which I was telling, this US and this CS2, and the H2S finally that is oxidized to elemental sulphur. This is the burning process which is taking place. This is the furnace of the super Claus reactor, where you are generating the sulphur compound. Claus process limitations. Thermodynamically, the limited conversion, the air to clean gas ratio is maintained to produce and ratio of the exactly 2:1 optimum ratio in the burner effluent gases. Increase H2O content to 30 volume percent, decreasing H2S and SO2 concentration, formation of the non-recoverable sulphur compounds due to side reaction. So, these are the some of the limitations in case of the Claus process. So, let us now discuss about the super Claus process, which I told you, because the problem in case of the Claus process, removal efficiency that was around 95 to 96 you can say, and the further removal that was necessitated, and so the tail gases again removal of the sulphur from the tail gases that has been incorporated. So, super Claus process was developed to categorically recover elemental sulphur containing Claus tail gas to improve the overall sulphur recovery level in the refinery. The super Claus process was commercially demonstrated in 1998, and today now more than 160 units are under license and over 140 are in operations. Super Claus process achieve high sulphur recovery levels by suppressing SO2 formation in the Claus stage and selectivity oxidizing H2S in presence of oxygen using the proprietary catalyst. This is the modified Claus process. Here you see the H2S, that is going to free flame reactor, oxygen stream, it is going to waste heat boiler, catalytic converter, sulphur condenser, from where we are getting the sulphur, and further treatment of the waste gas that is going. So, this is the modified Claus process then. So, what are the various actually units in case of the super Claus process? Combustion 7, Claus reactor, super Claus reactor, incinerator and degassing section. Super Claus process use selective oxidation catalyst, minimizes the side stream and increase the sulphur recovery. New development in the Claus tail gas treatment process. In the conventional Claus and its modified version process 90 to 97%, because I told you the 95, 90 that is on the higher side. Depending upon the efficiency of the Claus process, the emission that may be the your conversion that may be as low as 90% of the H2S and SO2 is burned. However, the remaining H2S and SO2 remains in the tail gas. That is the problem. That was the problem in the case of the conventional Claus process. Due to higher environmental regulation, there has been continuous development in the process and tail gas treatment processes. So, these are the some of the processes developed for the treatment of the gases: dry bed process, Lorgis sulphine process, Amoco cold bed absorption, direct oxidation of H2S, liquid phase subdew point process, that is the Claus Paul process. This is the another process that we are using in case of the liquid redox process. These processes use solution of the chemically chilled metal ion to oxidize H2S to elemental sulphur. So, these are the some of the commercial process which are available: Stratford process, sulphurin process, sulphrex process, low cat process, Castal process. These are the some of the processes that are available to meet the required environmental standards. Then the another process which has been developed by Sulphur process, that was by Indian Oil Corporation in India, that is the R&D center. They have developed this Sulphur process. I will be discussing the Sulphur process also. Mercaptan technology has also been developed, that is the by IOC also. Biological desulfurization process, that is the bioabsorption process. Sulphur G process, that is by the Gujarat Narmada Fertilizer Corporation in India. So, they are using this process, Sulphur G process, for removal of the sulphur compound. Super Claus, the big difference between the Super Claus catalyst and Claus catalyst is that the reaction is not equilibrium based. Therefore, the conversion efficiency is much higher than the equilibrium limited Claus reaction. Another feature of the Super Claus process: Super Claus is a non-cyclic process that has repeatedly shown simplicity in operation, high online reliability, and sulphur guarantees up to 99.3%. Now, let us discuss the Super process which has been developed by Indian Oil Corporation. Stringent environmental regulation has restricted high recovery of the H2S from the sour water ST per unit, because you see the sour water, that is also one of the major source, as I discussed from the refinery, because we are treating high sulphur crude oil in the process, and so the during the removal in the various section, the sour water that is generated, and the sour water from the sour water of the stripping the gases, that is going for the treatment. So, Super process ensures minimum H2S loss. The process employ additional hot feed flash drum upstream of the cold feed surge drum. Super process is a novel process approach for enhanced recovery of H2S from sour gas. The process has been developed by Process Engine Group of Indian Oil Corporation. Super process based on indigenous technology has been commissioned in the IOC Gujarat Refinery in 2010, because there are also a lot of the problem in Gujarat Refinery and emission of the sour gases, emission of the sulphur compound from this sour water, and so the process that was developed by IOC that has been commissioned there. The design helps in meeting the stringent environmental regulation of SO2 emission. Every ton of the sulphur recovered will eliminate 2 tons of the SO2 going to the atmosphere. So, this is how the recovery part that is very important. This is actually the conventional process and the comparison of the Suplhur process. Conventional process, flash dump to remove the hydrocarbon vapor and liquid from the source water, and they are having the feed tank and the stripper. Here actually some modification that has been done. This is conventional, because normally we are doing the stripping of the source water, and so these are the some of the units there. But if you see the compare this with your Suplhur process, so this is the some of the additional unit that can be added. Hot flash dump to liberate the enough H2S from this feed source water. So, this is the additional unit. Amine scrubber to recover H2S and ammonia from the hot flash dump, feed tank and stripper, because these are the that is also there in case of the conventional processes where we are stripping, we are treating the source water. But in case of the super, we have one hot flash dump that has been added, and amine scrubber is there, so that the emission that is. So, this is the advantage and the difference in case of the conventional process and the Suplhur process. In case of the Suplhur process, the H2S rich vapors from the hot feed flash dump upstream of the cold feed range, such dump is routed to a small amine absorber to absorb the liberated H2S. So, that is the I was telling that the additional unit which are having in case of the Suplhur Claus process, that is the the amine from the recovered from the this part. So, that is going to the amine scrubber, and then the better removal efficiency is there. The H2S lean gas containing primarily hydrocarbon then routed to incinerator of the sulphur recovery unit. The absorbed H2S rich amine is recovered in the amine regenerator and is fed to the sulphur unit for recovering the converting the sulphur to elemental sulphur. So, this is the process that they are using for the source water. Another technology that is that has been developed, that the mercaptan fiber film contactor technology. Even this technology that has been also developed by Indian Oil Corporation. The process is based on the continuous film contactor, fiber film contactor technology for removal of the impurities from hydrocarbon stream. So, this is the new development in the sulphur recovery process. The process achieves non-destructive phase contact without problem inherent in the conventional dispersive mixing devices. So, this is one of the, because the contacting that improves because of the continuous film contactor. So, this was about the sulphur recovery desulphurization process, and you see the as the our standards are becoming more and more stringent. So, they definitely the desulphurization process and the sulphur recovery section of the refinery, that is going to play very important role, because definitely the standards, because the Euro 4 we are having the 50 ppm SO2, we do not know what will happen in Euro 4, Euro 5 and Euro 6 in the future, because and at the same time the amount of the sulphur which is released, which is produced in the refinery, that will increase with the utilization of more and more crude oil which is available from the various sources. Now, actually there has been also the reason why the refinery, as I discussed earlier also, that the refineries now, many of the refineries they are going for the heavier crude also, because that is cheaper than the sweet crude, and so they are having the blend whatever the crude oil we are processing in the refinery, that is not only from the single stream, but it is blend of the, because definitely that will have to our requirement about 65% of the requirement that has to be made to the imported crude. And so the whole economy of the your process, that will depend upon the type of the crude you are processing. So these processes, the sulphur recovery and sulphur desulfurization process, because in the process we are removing sulphur, so that will play a part. In the next lecture, that will be on the petrochemical. Already we have discussed from the starting from the introduction to petroleum refining, and then the crude oil evaluation, distillation of the crude oil, then the some of the further conversion process that we are using the refinery. It may be the for the it may be the FCC, hydrocracker, or the catalytic reforming. So, all this process that we have discussed, and then the next part, that is the petrochemical, because in the future you may have the petrochemical refinery, not only the refinery, because the concept of the refinery is also changing. And so, the as I told you, the different now we are talking about the gasoline free refinery, we are talking about the GTL refinery, we are talking about the biorefinery. So, the next lecture will be on the introduction to the petrochemical industry.